Assalamualaikum and hi to everyone, especially to Dr. Sofia Najwa. So we are from group 22, which is group Paqueta dance, and we are from section 4. So for discrete structure subject, we're going to present about the shortest path from KL to Singapore. So without further ado, we jump into the key people. So we have 5 members in this group. So for the first, we have Arif, which is me. Next we have bro Irfan, and after that we have bro Syukri. Next we have bro Faiz, and the last one we have bro Aiman. Next we proceed to the list of contents. So for this presentation we consist of 5 topics. So for the first topic is case study. Next we have mathematical modeling. After that we have construction of math models. Next we have code development, and the last one we have analysis result. So for the case study, we need to proceed with bro Faiz. Proceed with that. Thank you.
We proceed with the discussion of this case study. So Malaysia was one country that have a many type of the transportation, include the public transport and the private transport. However, the number of all this transport will be increased every year and every day, because every person need a transport to move from one place to another place. And then this kind of the problem have in Singapore also. So based on our experience, the transportation is the human domestic. So all human need to move from one place to another place. So this kind of the mentality we need to change. Then Malaysian and Singapore have a discuss and meet to solve this situation, to decrease the number of transport in the road. So they conclude to make a project, HSR project, the high speed rail. That this project have been built around for a relationship between Malaysian and Singapore. So what is the HSR? HSR is a high speed transport project starting from the Malaysian at Kuala Lumpur until the Singapore Jurong-ish. This mega project also the present among developed the countries. For example, like the Japan, Chinese, American, and Russia. So this high-speed rail project was 2 or 3 times faster than the normal train. So this train will speed above 250 km per hour. So, in addition, this project has a specific track and a rolling stop. Lee Ting Heng, who was a Johor State investment trader, so he say this mega project can increase the economic, can make grow up after the effect of the pandemic COVID-19. So that means that he say we can cover all the costs for the COVID-19, to protect from a COVID-19 from this project, and then we can have a great relationship with Singapore. Datuk Seri Ismail Sabri Yaakob, who was a Malaysian former Prime Minister at that time, he said this 10 billion project who can cover a 350 km track in Malaysia, and they can include a 50 km track in Singapore. So all this track we cover by train only 90 minutes. So therefore this project have 8 station, the total start from the Kuala Lumpur and Putrajaya, Seremban, Aikro, Muar, Batu Pahat, Nusa Jaya or Iskandar Putri, and Jurong-ish in Singapore. So that is a last station. So this project will show that our country have chance to be a more competitive with another country in the future with this kind of the technology. Yeah. So I hopefully for this project we can determine the shortest speed rail routine between Kuala Lumpur and Singapore for this project, and make this research in analysis contract and approach discrete structure based on mathematical model. Then the model must be transformed into the programming code, and then finally guys, depends on the suggest design, we must to do a result analysis.
We proceed to the mathematical modeling. So for the mathematical modeling is a way of using math to represent and understand real life situation. It involves creating a mathematical equation and solution to predict how the system will behave. This tool is useful for fields like physics, economics, biology, engineering, and more. It helps to understand and predict the behavior of complex systems and can support decision making and problem solving. Mathematical models come in different forms and the appropriate one depends on the problem being solved. Example of models include differential equations, statistical models, and graph-based models. These models help in understanding and predicting the behavior of complex systems and aid in making informed decision and designing solution. So in this project, the goal is to identify the shortest route for the high speed rail, which is HSR, between KLs, which is we start from the KL Center, and Singapore, which is Jurong East. This will be done by mathematical modelings and considering this distance potential path. A figure is shown that depicts the possible shortest route. This is it.
Okay, next I will present about the third question, which is about the construction of mathematical modeling. As we can see, this is the graph I just built and a directed graph. This is a graph describing the route will have 13 edges as per the slide as shown, and connected to the vertices from Kuala Lumpur, KL Central, Kuala Lumpur to Singapore, Jurong East, and 8 vertices presenting the A train station. There are 6 possible routes from Kuala Lumpur to Singapore according to this directed graph. So we will go through the first route first. Firstly, the first route is from the KL Centre Kuala Lumpur to Seremban, then there to Batu Pahat, Nusa Jaya, and lastly we will go to Singapore Jurong East. This route have 5 station vertices and 3 edges make up 3 edges that are connecting to this path. As we can see, the total distance for this path is about 422.8 kilometers, and the second route is from KL Central, and then if we go to the Seremban, Air Keroh, and Nusa Jaya, Jurong East. This part consists of 5 edges and 6 station vertices. 5 edges that connecting to this path, and it have a total distance about 381.0 kilometers. And the third path is as you can see, from KL Central, Seremban, Air Keroh, Batu Pahat, Nusa Jaya, and lastly we go to Singapore, and it have 5 station vertices and 4 edges that connecting the path, and it have a total distance about 434.0 kilometers. And the fourth path is from KL Central, Air Keroh, Nusa Jaya, Jurong East. This part has 4 station vertices and 3 edges that connected to this path, and the total distance of the path is 372.6 kilometers. And the fifth part of this graph is from KL Central, Air Keroh, Batu Pahat, Nusa Jaya, and lastly we go to Singapore Jurong East, Singapore. This part have about 4 station vertices and 4 edges that connecting to this part, and its total distance is around 425 kilometers, 8.6 kilometers. And the sixth road is from KL Central, Air Keroh, Muar, Nusa Jaya, and lastly Jurong East, Singapore. The part has 5 station vertices and 4 edges, which have a total distance about 384.6 kilometers. And the 7th road is from KL Central to Putrajaya, then Muar, Nusa Jaya, Jurong East. This part has 5 station vertices and 4 edges that connecting this path, and it's also have a total distance about 409.0 kilometers. And the 8th road or 8th path or road is from KL Central, Putrajaya, Air Keroh, Muar, and lastly Jurong East. This part has 5 station vertices and 4 edges that connecting this path, so it will make the total distance about 413.3 kilometers. And the last road is from KL Central, Putrajaya, Air Keroh, Nusa Jaya, And lastly, if we go to the Jurong East, Singapore, this part has 5 stations, vertices, and 4 edges that are connecting to this path. So it will be a total distance about 401.0 kilometers. Next, I will pass this to next presenter. Thank you.
Hello, my name is Syukri. I will present about the code for finding the shortest path from Kuala Lumpur KL Central to Singapore Jurong East. In the project, use Dijkstra algorithm in Java programming language. The algorithm finds the shortest path in a weight graph with a source node to all other nodes. The coding use an undirected path, meaning the direction and the order of the vertices and edges doesn't matter, and the path can be traversed in either direction. The starting point is KL Central and the end point is Jurong East. The code for finding the shortest path between Kuala Lumpur and Singapore is written in Java using the Dijkstra algorithm. The figure shows the package used is Dijkstra and the class name is shortest path. First line of coding initiates the constant value -0, -1.0 to variable permanent number as double. Then it continues with line of method definition, which is Dijkstra method with parameters adjacencies and first of vertex as double matrix and integer. Each of the variables included are initiated in the method, and it continues with calculating the distance from the initial vertex to itself, which is 0 as the initial vertex. For loop are used to find the shortest path for all vertices and to find the nearest vertex. Last line of the coding is calling out the print solution method with parameters that are used in the Dijkstra method. Figure 4.1.2 shows the print solution method called in the Dijkstra method. This method has 3 parameters, which are first of vertex as double, distance as double array, source as double array. Start with initiating the U vertices as distance length, continues with print lines to show the shortest distance and station included in the shortest route. Next, figure 4.1.3. Figure 4.1.3 shows the print path method with two parameters, which are source2 as integer and source as double array. This method will show all the stations used by the shortest route in integer number and use if-else condition to name each of the stations to string. Next, figure 4.1.4 shows the code to print the table of routes from KL Central to Jurong East in the main method with distance. Next, figure 4.1.5 shows the code to print the table of the railway station with numbers in the main method. Next, figure 4.1.6 shows the adjacencies matrices declared as double data types, which are assigned as each of the vertices in the route based on the figure in figure 4.4. Last of the lines shows the code to invoke or call the Dijkstra method with parameters adjacencies and 0 value as the first vertex. Next, figure 4.2.1 represents the output of Dijkstra algorithm for finding the shortest path from KL Central in Malaysia to Jurong East in Singapore. The algorithm has chosen route number 4, which goes from KL Central to Ayekiro, then from Ayekiro to Nusa Jaya, and finally from Nusa Jaya to Jurong East. The total distance of this path is 376.2 km. The figure shows how Dijkstra algorithm evaluates and selects the shortest path from updating the distance of nodes along the way until it reaches the destination. That's all from me.
So next, I will continue with analysis result. So in this project, a high-speed rail is proposed to link Kuala Lumpur and Singapore for faster transportation. So the journey currently takes 7 hours by train and is slow. So the project involves finding the shortest path from KL to Jurong East, Singapore through 9 high-speed railway stations. So the duration of the journey will depend on which train is taken and the route chosen. So the station locations are interconnected. So, for our group, we solving the problem by using graph-based models to represent route from KL to Jurong East, Singapore. And each station is a vertex. So the train ride between two stations is an edge. And we also using graph theory algorithm to find the shortest path from KL to Jurong East. And the shortest path we found is from KL, Aikro, Nusajaya, and Jurong East with a distance of 372.6 km. And the shortest high-speed route between Kuala Lumpur and Singapore is been determined through graph-based mathematical modeling. Graph-based models represent the path as a directed graph with stations as vertices and train rides as edges. Algorithms such as Dijkstra and adjacency matrix are used to find the shortest path, resulting in a distance of 372.6 km through Kuala Lumpur rail station, Aikaro rail station, Nusajaya rail station, and finally Jurong East rail station. So the conclusion of the project is that the shortest path from Kuala Lumpur to Singapore was found using a graph-based model, Dijkstra algorithm, and adjacency matrix. The path is from Kuala Lumpur rail station, Aikaro rail station, Nusajaya rail station to Jurong East rail station, and the distance is 372.6 km. And that's from me. Thank you.
So that's all from us, and thanks a lot to everyone, and also to Dr. Sofia Najwa. Thank you.